Right. Welcome to this module. Here we're going to talk about different types of cells. We'll look at galvanic cells, we'll look at concentration cells, and we'll look at electrolytic cells. Like I said, outline, we're going to look at introduction to galvanic cells, types of galvanic cells. The galvanic cells are also called voltaic cells. Look at the applications. We'll look at the applications, and we'll also look at advantages and disadvantages of galvanic cells. Then we conclude. Galvanic cells are also known as voltaic cells. Remember what we said about Volta and galvanism. These are the two men who initially started this electricity or electrochemistry. It's an instrument in which a redox reaction is used to convert chemical energy into electrical energy. So galvanic or voltaic cells are used to convert chemical energy into electrical energy through oxidation reduction reactions. The reaction used for generation of electricity takes place in two different cells. Each cell comprises of a suitable electrolyte solution and a metallic rod known as electrode. So the setup is you have an electrolyte in a cell with an electrode. Of course, we are going to see that we have half cells which, when combined, will make up one cell. The cells comprising of electrode and electrolytic cells are called half cells. So this is what I mean by half cells. The moment two cells are connected via salt bridge and the electrodes to a wire linked with galvanometer, the electricity begins to flow. A very good example of galvanic cell is the Daniel cell. Types of voltaic cells. Remember we looked at a Daniel cell initially in terms of oxidation reduction reactions and what happens at the electrodes. Now we're coming practically to look at different types of voltaic cells. One is a mercury cell. Look at where they are used in our watches and cameras. Look at the battery here. As a cell, it's long lasting, it provides fixed voltage, but it cannot be recharged. That's a disadvantage. These mercury cells cannot be recharged. Another is the lead acid battery, the one we see mostly in our cars, lorries, buses, and trucks. It also provides fixed voltage. It is rechargeable, but it spoils fast. It is very expensive and it's also heavy. At this point now in Nigeria, batteries are very expensive. Some of them are up to 85,000 or even more. Nickel cadmium cell, which is for mobile emergency lights, it lasts longer and is also expensive. You have dry cells for our radio and touch. We all know this. We all use these batteries. It provides fixed current, easy to carry, but is non-rechargeable. Alkaline cell for radio and our touch, long-lasting and provide fixed current, but is also non-rechargeable and is expensive. Now we can see where galvanic cells can be applied. In fact, that is part of why we said initially the reason why we study electrochemistry, for us to understand the functions of this cell. The cells are used in many rechargeable devices. Mobile phones, laptops, solar cells, automobiles, antennas, and so on. These are the advantages. They last for a longer time. They are easily available. They provide steady flow of current and provide less fluctuations. Because they have disadvantages, some of them cannot be recharged. Some undergo rusting. Some are very expensive. And some need extra care as they will spoil easily. And some of them are bulky and heavy. Thank you very much. We've looked at introduction to galvanic cells, types of galvanic cells, the applications, of course, the advantages and disadvantages. I hope you enjoyed this module. See you in the next class. Thank you.